right, in chapter 25, what we're looking at is electromagnetic induction. We'll be talking about how generators work. Now, so first part, we're going to look at just electromagnetic induction, which is called Faraday's law. So, Mr. Faraday discovered that when you take a magnet and you thrust it into a coil of wire, it produces current, like magic, free current, free electricity. But is anything free? No. You had to do work, right? Pushing that magnet into the wire. So you did mechanical work, but you got out current, electricity, which is very cool. And so you get a voltage and a current. So, and we call that an induced voltage because you're forcing one to occur. So there's a voltage between the top of the wire and the bottom of the wire. Maybe it's 1 volt, maybe it's 3 volts, maybe it's 10 volts, but you got a voltage across the wires, and the current follows if you have a complete circuit. Okay, now the thing is that you can thrust the magnet next to the wire, or you can thrust the wire through the magnetic field. In either case, you get an induced voltage. And the more coils or turns or loops of the coil, then you get more voltage. So 2 loops here, maybe that's 1 volt. 4 loops, maybe you've got 2 volts. And with 6 loops, maybe you've got 3 volts. Okay, so it's proportional to the number of loops. Okay, so this is called Faraday's law. And so the law goes, the induced voltage in a coil is proportional to the number of loops multiplied by the rate at which the magnetic field changes in those loops. So that's the speed at which you are pushing the magnet into the coil. And of course, if you've got a bigger magnet, then that would cause a greater change. So that would also be something. So a bigger magnetic field, faster pushing, more loops, and you can make a very large voltage or current occur. Now, how much current do you get? That depends on how much voltage you induce. So let's say that you induce 5 volts. Okay, and then maybe you've got a 1 ohm resistance. Then you've got 5 volts, 1 ohm of resistance in the circuit, and we can use Ohm's law to get the current. Current is going to be voltage divided by resistance. So we would have that 5 volts divided by that 1 ohm of resistance, and that would give us 5 amps of current that's produced, right? So it depends on the voltage and how much resistance there is in the circuit. And the coil itself has some resistance. Now, as I said, there's no free lunch in physics. So when you are pushing that magnet in, then what happens is you have to use a force. Even though you think you can just drop it here, okay, you had to pick it up, so you did potential energy. So the thing is that as it goes in, there actually is an opposing force because the magnet, as you push it in, it is creating a current in these wires, right? It's creating a current in the coil. Well, it just so happens that that current that's being created creates an opposing magnetic field. So if you're pushing the north end of the magnet in, it will produce a north end opposing it. Okay, so an electromagnet, right? You've got current in a coil of wire, and so it opposes the incoming magnet. So you do have to push with some force. So yes, so mechanical work is done. That work is what's being turned into electrical energy. Now, the ring shooter is a lot of fun. Don't have one with me, unfortunately, but I will show you Faraday's law. But this also works by putting electricity through a coil, and that creates a magnetic field. And then there's this loop, and current starts to flow in that, and it creates an opposing magnetic field. And then that loop is popped off way up in the air. It's a lot of fun. Okay, let's go look at an example of the Faraday's law. Okay, so what do I need to do? I need to thrust a magnet into a coil of wire. So let's go look at this. All right, so we're going over here to look at an example of doing Faraday's law. Okay, so what I've got here is a galvanometer, right, which remember has a coil in it. And we're going to try and make a small current so that we can watch the needle of the galvanometer. Okay, we had too much light there. Let me turn this light down. Okay, there we go. Okay, all right. So right now it's at 0. And what I'm going to do is take a magnet and thrust it into this coil of wire. Okay, so I'm going to push it in, and you can see what's happening. I push it in, the needle goes one direction, I pull it out, the needle goes the other direction, right? So I can, it's, as long as I'm changing the magnetic field, if it sits still, there's no changing magnetic field, so I'm not producing any electricity. And so anyway, but by moving it in and out, I easily am creating electricity. And in fact, I'm making electricity that is alternating current, right? This is how easy it is to create alternating current. I just need to get some squirrels here to thrust this magnet in and out for me. But of course, I don't have to thrust it in and out. I can place it on a string and twirl it nearby, and it can also create a movement. Okay, so I can have a bigger coil and just spin it on a string. And so I can create alternating current very, very easily, which is why here in the United States, we usually work on alternating current because it's so easy to make it. You just need a coil of wire, a magnet, and some motion. And you can get that motion from a wind generator or water flowing over a dam, okay, or a steam power plant. So anyway, so there are lots of different ways to create this energy. Anyway, so about the only DC we get is from solar panels, okay, but AC is easy to make. Let me see. Oh, I was going to talk about this magnet. This is called a cow magnet, and the cow magnet is very smooth because they make cows swallow them, but it's very nice and powerful. Here's another one. And so the cow magnets are smooth, the cows swallow them. And so in something like a dairy cow that you want to live a fairly long life, the magnet goes into the first stomach and it picks up any nails or brads or anything that the cow might have picked up in its grass. And so that's what a cow magnet is. Nice, strong, smooth magnet that comes in a cow. Okay, so Michael Faraday was an amazing person, and if you watch the TV series Cosmos, there was a wonderful bit about Michael Faraday's life, but he just had this amazing life where he was born very poor, but he was very curious, and he started to attend free lectures, and then he wrote those lectures up and printed a volume for the author of the lectures, so then Humphrey Davy, and so then he was hired at the Royal Society where they investigated science and eventually became head of it after many trials and tribulations. But anyway, he was an amazing guy, and he had a lot of joy in discovering the electromagnetic effects. Okay, and that's the end of this, but also when you go to an airport for a metal detector, same thing. You are walking through a large coil. If you've got metal in your pocket, then what happens is that that metal, so let's say she has some metal in her pocket, the current starts to flow through the metal object, okay, because there's this large electromagnet here that you're walking through. And so what happens is it's sort of like an echo of the current flowing through that wire. And so because of that, they can actually detect metal objects. Okay, and so anyway, so it's pretty cool. All right, so that's the end of part 1. We're going to go on to part 2, generators and alternating current.